Hello everybody, this is Mr. 13 Things or Silence It Good, depending on what channel I post to, and of course YouTube is trying to make me make it one name, so that may occur as well. What we're doing here is we're picking up on top of the video that talked about using Extrude and Inventor. I don't have Inventor on this machine, but I'll get my daughters to get a copy, which they're allowed to have free download for any student. Go out to students, Autodesk and community and figure it out. And what I'm going to do is just going to do the same problem here just with software. Now if you notice there the way I started that, I'm going to keep that in. Remember, red is X, green is Y, and blue is Z. And I'm going to go ahead and put in a line. Start there, and if you notice here, I'm just going to kind of arbitrarily put it someplace. But now over down in the bottom right on my VCB, I'm going to put a hard, which is a hard bracket, and I want it to go to 1 in the X, 0 in the Y, and 0 in the Z. And I'm going to point out here, this is where I figured myself out that the world is going 3D, when Sketchup would not take a two-dimensional point. So it just did that. Before I do that, I'm going to go back and I'm going to do an edit undo, because I'm going to remember that no matter where I go, I always want to make sure I know my coordinate system. So I'm going to go to the model info, and I'm going to make sure that I'm doing this, and you'll see why over time I work in inches in SketchUp, even though it's kind of crazy, except for the fact that 2.54 centimeters exactly equals 1 inch if you're looking at an international foot and an international inch. You do this because the base unit in SketchUp, in some odd history of working with architects, is the inch. And so if you can train yourself at the start to that, then you can start working in the normal units you're working in. So the base units are inches. Once again, I'm going to arbitrarily pick a point up here. I'm going to use a hard bracket down there. I'm going to go 1 in the X, 0 in the Y, and 0 in the Z, and close my hard bracket. That does my first point. Now I'm going to kind of zoom in here. I'm zooming in with my mouse. I think I need to now give it another arbitrary point, unfortunately, and now I'm going to give it my next point. The next time I'll try to do better. 0, and this is 0 in the X, 1 in the Y, and 0 in the Z, close hard bracket. As it does that, if I just now go ahead and change this, which is 0 in the X, 0 in the Y, and 1 in the Z, right, you see what it does there. So I'm going to once again edit undo and edit undo. There's a lot better ways to do this, but I'm going to try to do one right now. Edit, erase. So I'm going to basically start now instead with a face. I'll go with a point here, there, and then I'm going up 1 and along that axis. And I'm just going to say 1. So what I did is I drafted in that direction and it's screwing me up, so I'm going to go back to where I started. And we'll disconnect those up. So you'll see when I get into the coding aspects, there are much better ways to do it. I'm going to click here, and I'm just going to tell it arbitrarily I want it to start where I started originally, which is 0 in the X, 0 in the Y, and 1 in the Z, based on that. Once again, didn't do it correct. 0, 0, 1. Right? Now I'm going to have to click here, and now I'm just going to be putting arbitrary points. That just finishes my command, and now I'm going to go to a point which is 1 in the X, 0 in the Y, and 0 in the Z. And I'm going to click out here, and then finally I'm going to click out to a point which is 0, 1, 0. What I'm pointing out right there, and I'm going to click out there. What I have now is these 3 points, and now I'm going to need to fill in the faces. At this point, I can use the ability of it to know that's it. Toward vertices 0, vertices 1, from there to there, and from there to there it closes it in. So I filled those in. I want to get rid of everything I'm dragging across, like kids will be able to do without even telling them. Erase. Now I've made that a lot more complicated than it needs to be. That's kind of okay, because what you're going to start learning is different software is going to have different interfaces. If I wanted to now, for instance, go from this point there, and instead of going exactly some point, if I wanted to use a relative in this program, it would be the less than symbol. I'm going to go 1, 1, 1, and you're going to see that draws in. I'm clicking spacebar, erase. What that did is that drew from that point relative 1, 1, 1, and that, if you think about it, is probably the direction that we're going to end up with when I'm done with this anyway. So I'm going to here. I'm going to go ahead and erase. All right, so somehow getting in a known coordinate system, again, what you can do is if students are starting in individual files to a standard datum, a really important thing in mechanical design is knowing what is your datum, what are your coordinate systems for each part, and then for the assembly at whole. So what I was going to do, if you remember, what I wanted to do is extrude this out a distance of 3. Here's all you've got to do that in SketchUp. You pull this out, take it out a direction, and then take your hand off the mouse, say 3, and now that is taken out a distance of 3. That now is essentially what we had done in the past with the mathematics. So we have, if we remember, we had 0.0, 1, and 2, and 0.01, 0.11, and 0.21 right here. So you could go about doing the labeling. You can do things like this in SketchUp. You can label there, and you notice there you start to recognize, you don't see the square roots in this case, but you start to recognize, if you're someone like me, 1 plus the square root of 3, or just the square root of 3, the square root of 3. And you're going to see that as I label through here, you tie it back to math and why, in fact, there is a value to start learning what is the decimal approximation for the square root of 2 and the square root of 3, square root of 2 being the Pythagorean number, or Pythagoras' constant, and the square root of 3 being Theodorus's constant. And so if I go around here, I'll kind of finish the other ones as well. I go ahead and label here in coordinates. Part of my point is here, so yeah, that's great movement, but if we don't keep the kids up at least conceptually in the mathematics of 3 dimensions when they're off doing this, you're not getting anywhere near the gains that you could be getting. And that's going to be a problem, I think, that computer science is going to solve if we start teaching our kids computer science. Because, I don't know, none of my people my age, what that is, and I'm about 50, know computer science anyway, or some of them do, the ones that are retired. And so all of a sudden you see we have labeled, in effect, 0.0, 0.1, 0.2, and then we've labeled each of these. And you can then, even with this program, start coming around and labeling each of my, remember that? That was a length of 3. Each of those were length. And if I grab the face here, I can label the face, and immediately it measures it as square inches. And so right in here, you realize, oh, boy, that's kind of interesting, right? So you have a whole lot of labeling, automatic calculation that can go on. But in effect, a lot of these calculations are just being done by basic linear algebra anyway. And so if you think about the area here is basically the cross product of these two vectors that will get you the area. The triangles, remember I talked a little bit about it coming from the cross product gets you the normal, but it also gets you, I think, twice the area of the triangle. So there's a lot going on here, and in effect here, right, we now have something that we can, if every student was doing it based on a standard coordinate system, but starting with different triangles, we could have them actually end up coming together. So something like this, I'm going to finish off and kind of show you what I then could do. I'm going to go ahead and assume I'm going to make this something, edit. I'm going to go ahead and get rid of these. I'm going across like students kind of know how to do, and we have to think about it. Going across versus a crossing versus a window is a big deal. I'm going to now use some basic good drafting skills, as I'm going to first go ahead, and this is a piece, so I'm going to right click over the top of it and make it a component, or make it a group. I'll just go ahead and make it a group. Over that, what I'm going to do now here is I'm going to take and draft a line from here, there. I'm going to take this out. If you know it locks that, I'm going to take it out a distance of 10. So right now I've got a distance there of 10. Now the problem now becomes is I want to rotate about something. I'm going to basically, what I'm going to do here is I'm going to go ahead and copy this. And I'm going to, what I'm doing is selecting my thing. I'm grabbing the N, hitting the Control or the Alt key, depending on what computer you're on. If it's a Windows, you're doing a lot of this in SketchUp. I'm hitting a Control key because I'm drafting in Windows on an Apple machine. Actually, if you notice there, I didn't quite do what I wanted to do. Edit, erase. So I'm going to take this. I'm grabbing, selecting, grabbing my tool, hitting the control key, grabbing from there to there. And in the end up here, what I have in effect is, right, I'm going to have the line there, and I'm going to now draft from the center there down to the middle there. And I'm kind of thinking now, I can kind of think that there's a plane in here that I want to do. So I'm going to go from here, from the center and up. And I'm going to go space bar. I'm going to click from here, the center, and up. And it's a lot, seems like a lot of work, but knowing what your planes are, all of a sudden I have something that I can grab here now. So what I'm going to do is I'm going to assume I have 24 students in class, right? That means I'm going to have this shape coming, 24 students in class, and this may come clear in a second here. I'm going to have each of them starting in a different set of coordinates or a different base plate as they put this thing together, and seeing how it all comes together by some prior thought. So if you remember, this was actually an object that was grouped, if you would. Now I'm going to use the copy rotate tool. I grab, so I go over the face that I want to lock my plane to. I hold the shift key. I grab here, I go down, and I'm going to go ahead and hit the control key again. I'm going to go up 15 degrees, and I'm going to say 23 times, or 23 times. And in effect now, if you notice, I have, right, effectively, you know, made some sort of rotating device, if you want to think of it that way, right, an axe. But what I'm using it for in the end is I could have done this mathematically. I can now explode each of these, and I can explode each of these. And realistically, you could do it another way. And now I can start having students go around and have starting at coordinates that are specific to every student. So that's a lot of work. It's probably a lot, but once you lay it out once, you can kind of do this a whole bunch of different ways, and students can see how these things come together. This is keeping students in one standard coordinate system, but of course the way Inventor works is each one has been working in their own coordinate system. So effectively, later on you can see that this was a pretty basic math. It would have been fair enough, easy enough to kind of just do a rotation. We're going to cover that another way. We would have actually done a rotation of this face, something like this. I'll go ahead now and kind of show you what it would have been doing if we're going to wanted to mathematically calculate the starting point. I'm going to go here. I'm going to basically move this whole thing from that, which was our base point. And now we're going to get back to why we use those hard. I want to go to 0, 0, 0 in absolute. And this probably would have been how you might instead have started about doing your calculations, because the logical point was at 0, 0. And if I go through here now, and we'll pick this up in the next video, if I have 3 points out here, and I'm going to label them again, now we're back to decimal. Because that's grouped, it's going to come as a group. I'm going to go ahead and explode, get rid of this, right click. And this is one of the things that sometimes Inventor is not so easy at doing. Do this again. I'm going to right click, erase. I'm going to label those 3 points. Right, so that would be the starting point for one student. Try it again, grabbing, make sure you grab, edit, undo. So I'm going to go ahead and pull this here. And one more time. Now, what you can finally see is there obvious was an axis of rotation, and so once we have these 3 points using either quaternions or basic 3D math, but probably quaternions, you could take this and actually had the program calculate each of the other faces for students to start. Knowing, of course, that they're all going to then extrude normal, so you'd want to make sure that you always had basically this is 1, this is 0.0, this is 0.1, and this is 0.2. But this concept are things we're getting students to do already, so why not play a little bit with at least starting to show them some of the 3D algebra. This got a little intense here, but with a little pre-work, you can have students kind of working each in the same shared coordinate system, and then making a device that works pretty well. Of course, this by itself probably wouldn't be so good. So as much as if I did something like this, I'm going to draft a circle. Now I'm going to hold the shift key. I'm going to the top there, right to that center point, which was our starting point. I'm going to draft this out. You remember, right around to there, I now have something that if I go ahead and I'm going to erase all this and erase, right, that I could all of a sudden go ahead and make it, right click, make it a group. And now all of a sudden now we have something that maybe might be a little bit more kind of standard in terms of being able to rotate, hold that down, right, rotate that around, put some time to it, sketchy physics. Thanks for listening. We will pick up on how to do the rotation with quaternions in another video. But in effect, this was a kind of an add-on video, mostly to show you how you can do the calculation of extrude in SketchUp. We will look at Inventor as well. Again, it is all linear algebra. Thanks for listening.